Okay, we're starting chapter 5, which is one of the money chapters. This one is interest and borrowing money. Back in chapter 1, remember, you learned about money as well. And so in this getting started, we'll do a little bit of review from chapter 1, really, and previous courses, because it's dealing with percents. So in the first chart, it says one column is percent and one is decimal. Remember, to convert from percent to a decimal, you divide by 100. So we're dividing by 100 here, and remember, when you're dividing by 100, it's moving the decimal place 2 to the left. So that would be 0.21. Vice versa, to go from decimal to a percent, we're going to multiply it by 100, and so that's going to move the decimal 2 to the right. It's still a decimal, but now it's a percent. That percent symbol, when it's drawn properly like that, really you can see why it was invented. It's a 1 with 2 zeros, and percent means out of 100. Second question, evaluate to the nearest cent. So this is money, and we're taking 5.5% of 90. So we want to write, as it says here, write these percents as a decimal. Some calculators will have a percent key that will do that for you, some won't. And so we really need to be able to do it on our own. So we're going to move the decimal to the left twice, just like we did up top here. So 0.055 of means multiply 90. Okay, so 0.055 times 90. And that's $4.95. Okay, and then the next one, same thing. Divide by 100, that's going to move the decimal 2 to the left, so it gets to 0.009 times 850. So 0.009 times, what is that, 850? 7.65, and it's money, so $7.65. Okay, next one. It says evaluate, so it's 250 plus 3% of 250. So notice how they even put brackets around that. Even if they didn't, of means multiply, so you know that you would have to multiply first. So basically, this is maybe like if you're buying something, maybe it's a tax of 3%, perhaps. So the original amount you have to pay, and then you have to pay 3% of that amount added on. So 250 plus, so let's do, I'll just do it above. Move the decimal 2 to the left, 0.03 times 250. Now, in your calculator, if you don't want to move the decimal, you could go 3, divide by 100, and there's your decimal form of the percent. And times by 250, that's 7.5. In money, that's $7.50, so we put a 0, and then we add those together. So you could do that in your head or in your calculator. It's going to be 257.50. Actually, now looking at it, there isn't a dollar symbol, so it could be any kind of calculation. So I won't put a dollar symbol in for this one. Next one I will, because there's dollar symbols. So again, it's 1,500, and then maybe a tax of some kind is 8.5%, so it gets added on. So moving the decimal 2 to the left is 0.085 times 1,500. So we'll get our calculator out. And again, if you're not sure, go 8.5 divided by 100 to get the decimal form, and then times by 1,500. and that's 127.5. Now, it is money, so I'll put the 0 for 50 cents. You always have to have 2 decimal places for money. And then we'll add those together, so $1,627.50. Okay, now this is review of interest calculations from Chapter 1. So principal, that's the amount invested, is 1,100. The annual interest rate is 1.55%, and the time invested is 365, which is 1 year. Okay, and this is the percent per year. So that calculation, to get the accumulated amount, we take the principal, which is 1,100, and we multiply it by 1 plus the interest rate per compounding period. So in this case, well, actually, I guess we're, complete the chart for interest compounded daily. Okay, so that means we're going to have to divide this by 365. So easiest way, so obviously we can't put a percent in, we'll use the decimal form, but we can do it all at once in our formula rather than calculating, because you don't want to round. Okay, so whatever you do, don't round until the end. So I would probably show it as the decimal form of that percent over 365. Okay, and it's 1 plus that. Then the number of times, if this is compounded daily, then the number of times it compounds is 365, because that's what the time is. So we don't really need to do this, in years here because of the question. Okay, so get out your calculator. So kind of depends on what version of the calculator you have. If you have just a scientific version, then maybe you want to do the interest, the interest first. Oh gosh, just want to move it over a little bit. Okay, so 0.155 divided by 365. So that's what you would get. Notice how it has an E -5 because it's times 10 to the -5. So it's a lot of decimal places. We're going to add 1 to that. So we're still inside the brackets. Okay, it's a really small number. And so this is what you would do if you don't have a graphing calculator like mine. You just do it in steps, order of operations. So we've done that. Then we'll raise it to the exponent 365. Okay, and then we'll multiply by the principal. That's how you do it on any calculator. On a graphing calculator like mine, which shows all the steps, you could just enter it all in. So it's money, and so 1,117.18. 1,117.18. Okay, and then it asks to calculate the interest. So this is the amount in the account after 365 days when this was deposited, right? 1,100. And so we subtract. So the interest is the accumulated amount minus the amount invested. So you might be able to work that out in your head, but it's $17.18. Okay. Okay, so the next one, we are investing $14,500. That's our principal. 1 plus, again, this has to be divided by 365. This is the annual interest rate, and there's 365 days in the year. So the decimal form is 0.0195 over 365 to the exponent 90. I'll show you in my calculator with a graphing calculator how you can do it in one step. So 14,500 bracket 1 plus, and then 0.0195 divided by 365. Just divides that percent. Then close the brackets for sure. Exponent just 90 days. Okay, so 14,569.89 when we round to the nearest cent. 14,569. And then the interest is the difference between that amount and what was invested. And so that was $69.89. Much more than the last because much more was invested, right? Because this is a smaller time period, a little bit higher interest rate, but smaller time period, but more invested. Next one, only 600. 1 plus higher interest rate, 0.021 over 365, and then raised to the 180. Almost half a year. So if we do it as if we didn't have a graphing calculator, then we do the 0.021 divided by 365 first, enter on that, add 1 to that, then raise to the exponent 180, and then multiply by the amount invested. So 606, again, 0.25. The 5 makes the 4 go up, so 606.25. Subtract $6.25. Okay. Last one here. 3,250. 1 plus. Okay, this is a small interest, so it's going to be 0.008 over 365. 275 days. I'll do this one as if I on my graphing calculator version. So the principal bracket 1 plus 0.008 divided by 365. Close the brackets to the exponent 270. So 3,269.29. 3,269.29. So then we subtract what we invested, and that will be $19.29. Okay. Okay, this one says Eric and Kay each invest $14,500 at 1.9% per year for 90 days. Eric earns simple interest, Kay earns interest compounded daily. How much interest does each person earn? Okay, so Kay, first of all, you might recognize this from the previous page. And that is this one here, 1.95% per year for 90 days. Okay, so 69.89. So we're not going to do the whole calculation. So K's will be 69.89. See previous page. Okay, but for simple interest, as we learned in chapter 1, we take our principal multiply it by, so here, in this case, that's the interest rate. So as a decimal, that's the yearly amount. And then the time, now we can do 90 out of 365 days. Now, if you wanted to divide this by 365, kind of like we did in the compound interest, and then multiply by 90, it would be the same thing. So 14,500 times 0.0195 times 90 divided by 365. So 69.72. Okay, so just slightly less than compound interest. And basically, because, so K earned more interest because it was compounded. So each day, interest was calculated and added on. Oops, calculated and added on, and then interest was earned on the interest. Obviously, not very much, right? How many? 17 cents, because it was only over 90 days at a small interest rate. But the more the longer you leave it in there, the more interest will compound, accumulate faster. Okay, next one. Each year, Kathy spends about $4,000 at a local store. The store offers 2 membership plans. Plan A is pay $45 and get no discount on any purchases. Plan B, pay $100 and get a 2% discount on all purchases. Which plan should Kathy choose? Okay, she spends $4,000 at a local store. Okay, so basically, it's the amount for Plan A. Oh gosh, here for keeps jumping. So for Plan A, she's going to have to pay the $45 membership fee, and then she's going to spend the $4,000. No discounts on anything. So overall in the year, she'll spend about $4,045. In Plan B, she's going to pay $100 plus, then she'll spend $4,000, but she's going to get 2% discount on all purchases. So really, what will she spend from that? So there's a few ways of doing that part of it. You might want to think, okay, well, if she gets a 2% discount, then she'll be paying 98% of what the sale prices are, basically. So that's how we could calculate the next part. So here we'll take 98% of 4,000. So what's that going to be? That's 0.98 times 4,000. So 0.98 times 4,000 is 3,920. And so total would be 4,020. So Plan B is best. Okay. Damien has a job as a nature guide near Prince George. He's buying $2,000 worth of fishing tackle. Today, if you buy $250 worth of fishing tackle, the store will reduce the price by 25%. Will Damien save money if he spends another $50? Okay, so if he saw this deal and thought, okay, well, maybe I'll spend $250 to get the discount, and maybe that'll still save me money. So you want to basically check out. Here they've done it in 2 steps. So reduce the price by 25%. So they're doing it by subtracting 25% of 250. Or you could just find what 75% of 250 is. That will give you the same final answer. So let's see here. So now in our calculator, 25% is 0.25 times 250 is 62.50. And it's money, so I'll put 2 decimal places. I'm not going to put the dollar sign until the end. And now when I subtract that, $187.50. And so this, he was going to spend $200. Now if he did purchase $50 more, actually he'll end up paying less than what he had planned. So will Damien save money if he spends another $50? Yes. This is less than $200. Okay, so that's the end of the try these. Then you can go on to section 5.1.